myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about data manipulation instructions. At the end of this video, the student will gain the knowledge regarding what are the data manipulation instructions and what are the various categories of data manipulation instructions like arithmetic instruction, logical instructions, and shift instruction, how to apply them while developing the assembly language program with examples. The basic agenda of this video is the introduction, data manipulation instructions, arithmetic instructions, logical instructions, shift instructions, and with examples. Instruction set architecture provides an interface between software components and hardware components of the system. The user perception is generally related to the software component while developing the programs. But these programs can be executed with the interleaved hardware components, and the interface that act between this software and hardware is the instruction set architecture, in short referred as ISA. So ISA is a part of abstract model of a computer that defines how CPU is controlled by the software. Not only the ISA act as an interface, but it also defines what is the memory model, how storage capacity can be organized, what is the instruction format, how the instruction can be divided into opcode and address, what are various categories of instructions, and what are various varieties of addressing modes in order to retrieve the operand effective address, and what are various registers, the types, and data addressing can also be described by the instruction set architecture. The instruction set provides an extensive set of instructions. So the collection of instructions to give flexibility to carry out various tasks. By using these instructions, the user or the programmer can develop the assembly language constructs. Instruction set is different from one computer to another computer depending upon the processor. The basic set of operations generally divided into three categories. One is data transfer instructions, second category is data manipulation instruction, and the third is program control instruction. Generally, the data transfer instructions can be used to transfer data or to move the data between registers or from memory to registers or from memory to I/O devices. The variety of instructions under this category are load, store, move. All these are the various categories of data transfer instructions that I discussed in the previous video. In this video, I will focus on data manipulation instructions. The data manipulation instructions generally used to provide the computational capability to the computer. So, various data processing instructions are available under the category of data manipulation instructions. The third one is program control instructions. This category of instructions are generally used to alter the execution sequence of the program. Now we will discuss what are data transfer instructions. The data transfer instructions generally move data from one place to another place in the computer without changing the data content. Generally, the transfer involves from processor registers to memory or processor registers to I/O or between the processor registers themselves. Now, what are the data manipulation instructions? Data manipulation instructions perform operations on data and provide the computational capabilities for the computer. Major data processing can be performed with the help of data manipulation instructions. There are three types of data manipulation instructions. They are arithmetic instructions. They can support basic arithmetic operations like addition, subtraction, multiplication, and division. The second category is logical and bit manipulation instructions. This category of instructions provide decision making capability to the computer. So generally these instructions include AND, OR, XOR, like. Next category of instructions are shift instructions to perform the left shift, right shift operations. The first category of instructions under data manipulation instructions category are arithmetic instructions. These instructions used to add, subtract, compare, increment, decrement, to find two's complement or decimal adjusting of the data can be performed with the help of arithmetic instructions. So the data processing or computational capability can be provided with the help of these arithmetic instructions. Both 8-bit and 16-bit operations are possible in case of arithmetic instructions. It is possible to write the code that allow data of higher precision to be operated upon. This extended precision requires the user to write code to support the higher precision. Architectures are also support the BJD binary coded decimal operations. The data can be represented in binary coded decimal form. The basic variety of instructions that can be available under arithmetic instruction category are: the first operation is the increment operation. So, to support the increment operation, the mnemonic that can be used is INC. The second operation is decrement operation. The mnemonic that can be used is DEC. The third operation is addition operation, and the mnemonic that can be used is add. Next one is subtraction operation, and SUB is the concerned mnemonic. Next one is multiply to support the multiplication, and the concerned mnemonic is MUL. Next one is division operation, and the mnemonic that is for the divide operation is DIV. Addition operation can be performed with carry and without carry. Without carry can be performed with the add mnemonic, and with carry can be performed with the add C. Subtraction with borrow can be performed with sub B. Without borrow can be performed with FCB mnemonic. Subtract and reverse subtraction can be possible with SUB or. Negate means negation operation can be performed with NEZ, the two's complement operation. Now we'll discuss what are the arithmetic instructions. The first arithmetic instruction is increment instruction. What is the register that is specified in there with the INC mnemonic? The register value can be added by 1 and is stored in the register. So, next is decrement. Decrement is used to subtract a value 1 from the register or from the memory word. Add performs an arithmetic addition on the values stored in specified registers or the memory word. Subtract performs the arithmetic subtraction on the values stored in the specified registers or the memory word. Multiply performs arithmetic multiplication on the values stored in the specified registers or memory word. Divide performs arithmetic division on the values stored in the specified registers or the memory word. Add with carry performs the addition on two operand plus the value of the carry from the previous computation can also be considered in the add with carry operation. Subtract with borrow. Subtract two words and a borrow which may have resulted from a previous subtract operation. Negate produces 2's complement of the value stored in the register. Now we will look into the examples how to apply these arithmetic instructions. INC is used for increment operation and the register specified in the INC is the R1. The value stored in the R1 can be 1 can be added to the value stored in the register R1 and the result can be again stored in the R1 register. So here R1 is equal to R1 plus 1 operation can be performed with the help of this INC. While using the decrement operation, what is the register specified is the R2. The value stored in the R2 can be decremented by 1 and the result is again stored in the register R2. Next is addition operation. So here the two registers that are involved in the addition operation can be specified with the add mnemonic. So here the source register is the R1 and the addition of the values stored in the R1 and R2 can be performed and the result is stored in the R1. In case of subtraction, the result storing register is R1. R1 minus R2 can be performed with the submnemonic. In this way, the arithmetic instructions can be used. Next, we will consider the sample program. So here, if the user want to perform J is equal to K plus M. The K value first moved to a register. So here, with the help of the combination of data transfer instructions and data manipulation instructions can be used in this sample program. MOV is a data transfer instruction. It moves the data without changing its content. The K value can be moved to the AX register. Next, add AX comma M. In the AX, the K value is already moved. So, with is adding K plus M and the result is again stored in the K. So, that is the AX register. Next, move J comma AX. The result obtained from the addition is stored in the AX. That value can be moved to the J in order to perform J is equal to K plus M. Next sample program is J is equal to K plus M plus N plus P. So first the K value can be moved to the AX register and the M can be added with this. Here the K plus M operation can be performed and the result is stored in the AX register. So with this again the N can be added. So K plus M plus N can be performed and the result is stored in the AX. With this, the P can be added. So, K plus M plus N plus P can be added and the result is stored in the AX. This result can be moved to the J to evaluate the expression J is equal to K plus M plus N plus P. In this way, the data transfer and manipulation instructions can be used in the program. By using variety of addressing modes also, these arithmetic instructions can be specified. So here the add instruction can be how to apply add instruction in immediate addressing mode, register addressing mode, direct and indirect addressing mode. So in case of immediate addressing, the hat symbol is used to specify the data address. Next, in case of register addressing mode, register values can be specified A comma RN, accumulator and the register, general purpose register. Next, in the direct addressing mode, accumulator, comma, the direct address of the operand can be specified. In case of indirect address, @ symbol can be used preceded by the register value. In this way, the 4 addressing modes can be used in the add instruction. So, similarly, in the add C also, in case of immediate addressing, the hash symbol can be used. In case of register addressing, the register number can be specified. And the direct addressing mode, the memory address of the operand can be directly specified. And in case of indirect addressing mode, @ symbol can be used to specify the indirect address of the operand. In case of subtraction with borrow also, the 4 addressing modes can be applied. The division, multiplication and division can be specified with 2 values. And in case of decrement also, we can use the register direct and indirect addressing modes. So like this, the arithmetic instructions can be used with the variety of addressing modes in order to specify the effective address of the operand. The second category of data manipulation instructions are the logical or bit manipulation instructions. The logical instructions perform binary operations on strings of bits stored in the register. So here, logical instructions consider each bit of the operand separately and treat it as Boolean variable. So these logical and bit manipulation instructions can be applied on the strings of bit values stored in the register. A single bit can also be retrieved and used in these type of instructions, and this single bit can be treated as a Boolean variable. By proper application of the logical instructions, it is possible to change bit value to clear a group of bits or to insert new bit values into the operands stored in the registers or the memory words. So, bit manipulation can be supported with the help of these bit manipulation instructions. The list of logical instructions are clear instruction. It is used to store a 0 value in the specified register, and the mnemonic that can be used is CLR. To complement, COM mnemonic can be used. To perform AND logical operation, AND mnemonic can be used. In order to perform OR logical operation, OR can be used. Exclusive OR operation, XOR mnemonic can be used. To clear the carry, CLR-C. To set the carry, SET-C. To complement the carry, COM-C. The interrupt can be enabled with the help of EI, and interrupts can be disabled with the help of DI mnemonic. So these are the list of logical instructions that can be generally available. The clear logical instruction is used to store a 0 in the specified register. The complement instruction is used to produce the ones complement of the stored value on the register. So here the ones complement can be obtained by interchanging 0 as 1 and 1 as 0. To perform Boolean AND operation on the individual bits, and mnemonic can be used. Similar way, to perform OR Boolean operation, OR mnemonic can be used. So these operations can be applied on individual bits of the operand. Similar way, to perform exclusive OR Boolean operation, XOR mnemonic can be used, and this operation can be applied on individual bits of the operand. Clear carry is used to set the carry bit as 0. Set carry is used to store a one value in the carry bit of the register. Complement carry is used to produce the ones complement of the carry bit. Enable interrupt is used to enable the interrupt with the help of flip-flop in order to indicate that interrupt is raised during the program execution can be indicated by enable interrupt, so that at the end of instruction cycle, after completion of 4 phases of the instruction cycle, the computer can look into whether any interrupt is raised or not. The raising of interrupt can be done with the help of EI. If it all interrupt is raised, the program stops its execution and it can suspend it temporarily the current execution of the program, and it can transfer the control to the interrupt service routine, and the interrupt service routines can be executed, instructions can be executed one after another until it find the return statement. As soon as a return statement is encountered, the control again return back to the main program and resumes the program execution. So this interrupt is raised by the EI instruction, and it can be disabled with the help of DI mnemonic. The disable interrupt can be disabled the interrupt with the help of the flip-flop. So these are the varieties of categories of the logical instructions. Now how to apply them? So here CLR C. So the C can be, the carry bit can be stored with a 0. Set C means the C can be, the carry bit can be set with a value 1. CPL means complement value can be stored in the carry bit. So here ANL means and logical operation on each bit, individual bit of the C register can be applied. ORL means all logical operation can be applied on individual bit of the register C. So in this way the logical instructions can be applied in the assembly language programs. The third category are the shift instructions. Shift instructions are operations in which the bits of a word are moved to the left or right. Shift instructions may specify either logical shift, arithmetic shift, or rotate type of operations. So majorly 3 categories are there in the shift instructions. What is shift left and what is shift right? Shift left operation, the serial input transfers a bit to the rightmost position. So here on the left side, each bit has to be moved to the rightmost position. So in the shift right operation, the serial input transfers a bit to the leftmost position. So these are the shift left and shift right operations. And what is the logical shift micro operation? Left shift operation. So here consider this is the register containing this value, and each bit has to be moved to the rightmost position by using the left shift operation. So at the 0 position, LSB position value can be moved to the first position. So this one can be moved here to the first position. Next one, next position 0, like this. The all bit, individual bit can be moved to the leftmost word. And here whatever the MSB that is left can be discarded, and the vacant position that is created at the LSB can be filled with a 0. This type of operation is referred as left shift micro operation. What is the right shift micro operation. So here the bits has to be moved in the right side direction. So here the values that is exist in the MSB can be moved to the next position. So like that the each bit has to be moved to the right side direction, and the LSB position can be discarded, and the empty position that is created at the MSB can be filled with 0, is referred as right shift micro operation. Next variety of shift operation is arithmetic left shift micro operation. A left arithmetic shift of one position moves each bit to the left by 1. The vacant LSB is filled with 0 and the most significant bit is discarded. So it is identical to the left logical shift that we discussed. So each bit has to be moved to the next highest position, and the vacant position at the LSB is filled with 0 and the MSB can be discarded. Next is arithmetic right shift micro operation. A right arithmetic shift of one position moves each bit to the right by 1. The least significant bit is discarded and vacant MSB is filled with the value of the previous MSB. So here right side each bit has to be moved. So here what is the MSB bit that can be copied to that MSB position and the previous next position also. The remaining bits can be moved by right by one position. The LSB can be discarded. So this is the right arithmetic shift. So what is the difference between logical shift and the arithmetic shift? The logical left shift and arithmetic left shifts are the same, but a right logical shift of one position moves each bit to the right by 1. The LSB bit is discarded and the vacant MSB is filled with 0. But in case of a right arithmetic shift of one position moves each bit to the right by 1, the least significant bit is discarded and vacant MSB is filled with the value of the previous bit. So here it is identical to the left shift operation, but in case of shift right operation, the MSB can be filled with 0, LSB can be discarded. But in case of arithmetic one, the previous position value can be copied to the MSB position. So that is the difference between the logical shift and arithmetic shift. What is the purpose of arithmetic shift? So arithmetic shift is generally used for the multiplication by left shift. The result of left shift operation is a multiplication of 2 power n, where n is the number of shifted bit position. Let us consider an example. A decimal number 2 is represented as 4-bit number. This is the 2 value that can be represented in 4-bit binary number 0010. By shifting to the left with one position, we will get the 0100, which is a equivalent to 4 value in the decimal representation. If you shift it once more, we will get the value that is equivalent to 8 in decimal representation. So thereby it supports multiplication by the value. What is circular shift? The circular shift circulates the bits in the sequence of a resistor around the both ends without any loss of information. So in previous cases, the discarded LSB is there. So there is a loss of information. So but without loss of information, that has to be moved to the MSB position. So here they are shifting left circular shift. Each individual bit is transmitted by one bit, but here what is the bit that is left at the MSB can be used to fill the vacant position at the LSB. So this is the left circular shift. Next is the right circular shift. So similar way, each and individual bit of the register can be moved to the right side by one bit position. And what is the bit that is what is the position that is vacant in the MSB is filled with the LSB bit, that is referred as right circular shift operation. What are the various instructions to support these shift operations? Logical shift right operation, the supported mnemonic is SHR. Logical shift left operation, the supportive mnemonic is SHL. Arithmetic shift right operation, SHRA. Arithmetic shift left operation, SHLA. Rotate right can be specified with ROR. Rotate left is specified with ROL. The rotation operation can be performed with a carry. Rotate right with a carry, RORC. Rotate left with a carry, ROLC. So these are the list of shift instructions and the mnemonic concerned mnemonics. Now we'll look into what are the examples of these shift instructions. SHR means shift, right shift by the R1 register value by 1 bit. SHL means shift left the register R2 value by 2 bits. SHRA is used to perform the arithmetic right shift on the register R1 by 1 bit. Similar way, SHLA is used to perform the arithmetic left shift on the register R2 by 1 bit. ROR means rotate right R1. ROL means rotate left the R2. With carry, RORC means rotate right with carry of the register R1 value. ROLC is the rotate left with carry of the R2. So in this way, the shift instructions can be applied. So in this video, we have discussed about the data manipulation instructions. The data manipulation instructions are majorly used to perform the processing capability or computational capability to the for the programmers. So here we are having three types of instructions: arithmetic instructions, logical or bit manipulation instructions, and shift instructions. So, what are the various mnemonics concerned for each category and how to apply them with examples we discussed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.